So this is an SMT stencil. It's a piece of plastic film. This case is 3 mil thick, 3/1000 of an inch thick. It's very flexible, transparent. Most stencil companies will tell you exactly what it is, and they'll mark on it the product code or version number or what have you. The way it works is the stencil is used to lay over the board, and I've shown you what the pattern of the cutouts is. Essentially what we're looking at here is the holes in the stencil correspond to the surface of the board that you're going to be covering in paste. So these are laser cut little holes. You can't really see that, I know. So that's actually what it's basically what it looks like. And that matches exactly the solder pads on the board. Like that. The next step is to put the board into a jig. It sits very accurately into the jig holder like that, board holder. You lay the stencil on top, and then we use a squeegee or a spatula or whatever you have handy. It has to be very, very smooth on its edge like that, and basically we're going to just like squeezing drywall paste on. We're just going to smear the paste into the onto the board like this. Okay. If you make a mistake, it's very easy. You lift it up, clean it all off, and start again. One thing though is this scraper has to be extremely smooth. No lumps, bumps, or roughness to it at all. If it does, it'll simply scrape away the solder where you don't want it to do that. So it's a very smooth process. Solder paste comes in tubs. This sort of product by Chip Quick. I'm actually using a leaded solder in this case. It's got a lower melting point. I like that. It's a little less stress on the components, I think. It's also a little easier to use a soldering iron, hand iron, if you have to rework things. So here we go here. I'm just going to run this through the stencil. Got a little bit of goop on my spatula here. Like that, and it's just a smooth process. You just don't want to work at this too much. Like that. Problem is, you know, if you do work at it, what it tends to do is it smears the solder underneath the stencil, which is badness, and wastes solder and wastes your time. Look at that, I've got a tiny little nick in my spatula there, and it's actually making a mess. So I'm not going to be able to use this one, I think. Nope, that's making a mess. Okay, start again. Just clean it off, pick it back up. This solder paste is pretty expensive stuff, so I really prefer not to waste it. You also got to be very, very careful you don't damage the stencil on the way. Well, just recover that and we'll clean up and start again. So that was a bit of a mess. Clean up is just as easy as rubbing a little bit of denatured alcohol over the whole shebang. There we go. Clean top, clean bottom, clean the board of course. Be perfectly clean. Any residue of solder or flux right off the board. I want to make sure there's absolutely no lint from the cloth on there. This has to be a very clean business. You be very gentle with the stencil as well, because quite easy to crease it or chip it or cut it when you're being a little rough. That's good, and dry that all off. I'm pretty happy with that. Another wipe over the top. Actually, it's a good idea to rub your board with alcohol before you start doing this. It just gets any grease off the surface, you know, where your grubby little fingers have touched it. So that's not that design. The spatula I was using before there had a little tiny nick in it. I can barely see it, but I can just feel it. It's just there, and it's just enough to pull the solder paste back out of the holes of the surface. So I've got a brand new one here. It's undamaged and perfectly smooth. And this one, I'll just do the same thing with that. Just work it through like that. So here we go again, another try. Not want too much goop, that's about right. Yeah, it's a bit better. To hold the board down onto the, sorry, hold the stencil down carefully onto the board, a bit of tension, so that the paste doesn't creep underneath it too much. Yep, and that's about that. Lost a little bit there. There we go. There we go. Alright, that looks pretty good. You can just work over it with a reflective light at a certain angle, and you'll pick up if there's solder paste missing. Oh, yeah, pretty happy with that. Peel away the stencil, lift up the board. Okay, now this one I just squeezed a little bit too much in there, and there's a couple of spots where there's an excess of solder. I clean that off. Very careful. It's actually not that big a deal, because the board itself, the white part of this board, usually is green or blue or whatever, but that's called a solder mask, and it's like oil and water. It won't allow the solder to glue onto anything other than where the board was actually bare, so where it's intended to go. A little bit of touch up there. Okay, that one's just perfect now. So I've got two of those ready, and I'll just run those now through the process. I'll add the parts and put it through the oven again, and then I will have 6 boards done. Alright, this is the work tray here with all the SMT parts organised on it. What we're trying to do here is make sure that the pattern of bits and pieces kind of matches the board in the first place, and secondly that all of the parts are correctly counted into the various compartments. In this case I'm making 5 boards. I've got 3 assembled. I'm going to make 2 more, so there should be enough parts in the tray now for 2 pieces, of 2 pieces for each board where needed. So this is basically an error check. At the end of the day, if I've got some bits left over, I go back and verify that I've not missed something on one of the boards, or otherwise I've miscounted. So the workspace is very clean, very organized. I have my SMT board unpopulated. What I've done already is I've used the stencil to mask this and apply a little rubber solder paste over it. And the end part of this little process here is creation of a board with all the parts laid on it, and then it goes through the reflow oven and it produces an end product like that. So this one's all built, tested, and works just fine. So just to give you some idea, the little black chip in the center there, there's my fingers and a tweezer. That's less than a 1/4 inch. It's about 4 millimeters, I think, across. And some of these smaller pieces here are about 1 millimeter across. These are the LEDs over there. That's a timer chip. This is the counter chip. Various resistors, capacitors, and what have you. The board is designed so that once you put the lamp and the lens on it, that can be assembled just as one piece and used as one piece. But then if you want, you can also break away the lamp and mount it separately from the control board. And secondly, that the lamp itself can be used on its own with another control board, so we get 2 lamps running on the same side of the circuit. In other words, we can daisy chain from one controller to 1, 2, 3, 4 on one side and 1, 2, 3, 4 lamps on the other side, making for a very bright display. So what we're going to do here is pick up these parts with tweezers, very fine tipped tweezers, and lay them right on top of the pads on the solder paste in a way that means that they don't smear or move around or whatever when the solder is actually melted. Try to be quite accurate with that. Just give it a little touch, press it down. Each of the parts has an orientation, of course, up and down, left, right, so you have to be very careful about that. What we want to do is make sure that all the pads and the feet of each of the chips are correctly aligned and not sort of missing contact in any place. Very precise process. Once again, just put it in and tap it down. And I'll do this for all of the other pieces on the board. It takes a couple of minutes to get this done. Unfortunately, the camera and camera angle here is not helping my vision. We'll get this all straightened out in a moment. There we go. So now I've got 2 IC chips on here. You can barely see this, but there's a transistor there and another one down there, and the 2 LED chips over here from Nichia. So now I've added 2 small capacitors right there and a Zener diode chip right there. And finally, I'm going to place the 2 power resistors on the board. And these guys are there because these LEDs pull a fair bit of current, but we don't want to give them too much current because they can blow very quickly and they get very, very hot. So there's a board. Compare that with my other boards. Here, make sure there's nothing missing. We'll be ready for the oven in just a moment. So there we are, there's 3 boards ready for the oven. I just double check. Make sure every part is in place where it should be, there's no misalignment. That actually looks pretty good. So there's 3 boards ready for the oven. So there's nothing terribly clever about this. It's a standard toaster oven. and I've just got the plate on the top here upside down, so it protects the bottom of the board from the very intense radiation from the heater below. Inside there's a thermocouple, very small sensor right there that measures the temperature inside the board. Not quite so interesting is a little box off to the side here. That's the PID controller. PID is the power integral derivative control board, and a little bit of software there to run that. It's currently showing me I've got, I don't know, 49 degrees or something inside the device. And this is the graph showing the change of temperature over time inside the oven, and it's quite carefully controlled, because when you buy solder paste solder, it has a profile, a temperature profile like that, and there's an area here called preheat. It brings it up to a certain point, in this case 150 degrees, that's preheat. And then we have an area called soak, it's up here, and make sure that the solder is starting to melt, the flux is ready, all the components are bedded down properly. And then finally a little area here called reflow. And reflow is when the temperature goes right up to the top, absolutely over the top of the melting point of the solder, and very quickly drop back down now to cool down. And on the chart here on the screen you can see just exactly what that looked like previously. So I'm just going to start this guy up. I'm going to warm it up a little just to get the oven ready so the preheat doesn't take quite so long. I'll just start that, get the profile going. I'm going to use Kester solder profile. I have a Kester solder profile I previously established, which is the preheat for 150 degrees, 180 seconds, soak 183 degrees for 90 seconds, and then a reflow at 235 degrees for about 120 seconds. Warm oven. Just being very careful here not to knock anything off the board so it doesn't displace or get out of alignment anywhere. It looks pretty good. So they're ready to go. And we'll just start the ramp. And here we go.
Starting preheat.
And off it goes. So that'll sit there and cook for about 5 minutes.
Starting reflow.
So now the temperature is going to ramp up quite quickly for a fairly short amount of time, just to go up over the top of the graph and up top of the mountain and down the other side. And as soon as it's done, I'll open the oven door and cool things down pretty quickly. So it should get up to about 235 degrees. And what's actually happening inside the oven at the moment with the PID controller is it's turning on and off the oven heater very, very quickly. On, off, on, off, on, off. And it's doing it at the same time as it's measuring the actual temperature. So if it starts to overheat, it will turn off the oven for a little longer and begin to cool down just a little bit until it reaches where it thinks it should be, and then it'll turn it all back on again and then off and then on. And that's why the graph is slightly wiggly at a very high resolution there. It goes up and down plus or minus 1 or 2 degrees as it climbs. And that's just the machine learning how quickly the oven is responding to the heater going on or the ambient air cooling everything down again. We're just about done there. So we're up to temperature. And it sits there for a few more seconds until it begins to cool down. go, and I'll just help that cool down and open the oven door there for a moment. It'll rapidly cool down now to 70-80 degrees. Then I know the solder is absolutely solidified again, and at that point it's safe to move it. So there we are now, we're cooled down to about 75 degrees, and that's pretty safe to handle. So I'll pull those out, I'll take them over to the bench and test them. See what happens. Plug the first one in. Oh yeah. Blinky blinky. Now that's the basic light, and of course as soon as I put a lens system on that, it's many times brighter. Very, very intense actually. Can't look at that. Hopefully it doesn't hurt the camera too much. First one. Second one. Third one, and fourth one. So it's actually a very reliable process, this SMT business, more so than hand soldering. I find it's a little complex to get started in it, and it takes a lot of time, and certainly an investment in your own time and learning, and in the equipment, of course, in order to get things ready. But there's several steps to it, as you saw. We start with a manufactured board. So we get boards from your favorite board house. Of course, I design these, of course, using various software. So there's the board. It comes beautifully made, in this case from a company offshore. Very nice quality. Not cheap in this quantity. I mean, there's only 20 boards here, and that was, you know, working out around $10 a piece probably. Once you got the board, next thing to do is to stencil it up and, you know, assemble it from that point onwards.